All right, there we go. So for those who are unfamiliar with us, /Lit is an online zine for electronic literature, and we seek to bridge literary and creative coding communities with our online publications that showcase experimental art and writing that use computing as a medium. Currently, we are seeking work for our 6th issue under the theme Zip Freeze Bundle, and we're looking for things like code poetry, interactive fiction, generative art and writing, and multimedia work. So I'll put some information in the chat near the end of the workshop if you're interested in contributing. And I'd like to note that proceeds from this workshop ticket sales are going in support of the Internet Freedom Foundation, a digital liberties organization based in India. So thank you for those who donated already. I'll be sending out proof that your donation was received after Eventbrite distributes these funds. And I'll also be putting a link in the chat near the end of the workshop in case you didn't get a chance to donate yet. Let me just admit some people from the waiting room. And now I'd like to welcome our workshop host for today, Hetvi. So Hetvi will be running a workshop on generative art using the JavaScript library p5.js. Hetvi is an undergraduate student based in India and the co-founder of Hetvi, an art and lit zine letter interested in the relationship between art and technology, amongst other things. You can find Hetvi on Twitter at @VuisNotABot. And without further ado, Hetvi, take it away.
So hi everyone, thank you so much for showing up. I'm just going to share my screen. So let me know if you if someone doesn't see my screen, please let me know. One thing that I sort of like to do is before we start with anything very formal, I just want to show you these 3 images, and I want you to guess which one out of these 3. So two out of these 3 are images that were created using like photographic techniques with microscopes, and one of the images is generated using code. So would anyone like to just guess which image it is, perhaps? I found this to be a very interesting exercise because it can really show us that something so mechanical can generate things that look very organic and are, you know, different. It's difficult to like guess what is real and what is not when it comes to generating art with code. So Mario Guzman guessed that the third one is a computer generated. Unfortunately, no. The second one is the computer generated image here. So without further ado, hi, as Caroline introduced, I'm Hetvi, and I am extremely grateful to /Lit for allowing me to like conduct this workshop. Thank you so much. Let's get started. So before we talk more about generative art, I would like to get a sense of what you think it is, and what were the expectations, or what were the things that came to your mind when you heard of this term generative art or creative coding, or even the title of the workshop, which is like Through the Coding Glass, Generating Wonder Algorithmically. So what does generative art mean to you? From like you might be a newbie, you might know a lot of things already about it, but I'm just curious if you could share in the chat what it means and what you think. What do you think or feel about generative art, or how you felt about it while signing up? I'm quite curious to know. Generating. Yeah. So one of the questions is, who is the maker? Is the maker the human, the person who creates the algorithm? Is it the computer? Like how does one view creating art using a computer? Because who is the creator here? And a view that I personally like to what I think of generative art is, it is just a series of happy accidents. Because often when I'm making something using P5, FGL, anything, I would just like, it would just be like, okay, I tweak so instead of a sign, I just tweak it and make it a tan, and I get something that's splendid and just out of this world. So it is a bunch of happy accidents, and it's just exploration in some sense with the computer at uh, with a computer. So yeah, someone talked about how generative art is there in NFTs. So yeah, NFTs are a great example of a place, arena rich with just a lot of amazing generative art. So the question of who is the maker is a bit more convoluted, but but the way that I like to think of it is a collaboration with a machine. So the machine does not necessarily need to be a computer. It is like collaborating with an autonomous system of some sort. It is collaborating with an algorithm. If you're using a coin, then it's collaborating with a coin. So generative art is all about designing steps to collaborate with machines. And it is not something very new. Like these are two examples that I would really like to show. So one of them is Exquisite Corpses, which is so it was said to be like a product of the surrealist art movement. And the idea is that you can mix and match faces, torsos, and bottoms to, in some sense, generate new characters. So there is this element of generativeness even there. And this, the thing that you see on the right side, it is a sheet of, so it's a grid, but this grid is something that was actually used by some musicians from like the 17th, 18th century to generate music or generate parts of their opera using randomness in the form of like rolling a dice. So it's very interesting. It is an interesting art form, and it's not recent also. It has some pretty deep roots. So just to illustrate an example generative algorithm, what I'm going to do is I'm going to show you this simple series of steps. And by the end of the workshop, what we'll try to do is we'll try to convert this to an algorithm and implement it in p5.js. In the process, learning a lot of things about p5.js. So first, I'm just going to talk through this simple series of steps and talk about how it generates, like what sort of a thing it's generating, etc. So let's just go through the steps once. So step one is I will roll a die. Step two is if the roll is even, I will draw a circle anywhere I want. Step three is if the roll is odd, I will choose a circle that's already drawn and make a triangle inside it. If nothing is drawn, if nothing is there on the canvas, then I'll roll the die. And I'll repeat this till I'm tired. So what I want to do is I want to do like a few iterations of this algorithm live, just, and if it is possible for you to get a piece of paper and a pen, I want you to do this exercise with me as I do it on the screen. And in this process, we will be able to see how we get very different results even when we are doing the same series of steps, because in this case of our subjectivity or like the randomness that we introduce. So let's go for it. The first roll is thankfully even. So if the roll is even, I will just draw a circle. Then I will roll it again. The roll is odd. I will draw a triangle inside that circle. Another odd roll. I will draw another triangle. An even roll, I will draw like a huge circle. So I hope you get, I'm sorry about that. Let me get some water. So I hope you understand what the steps are doing. So essentially, we're generating a sketch made of circles and triangles just by rolling. So we roll a die and we follow the steps and we proceed in this iterative manner. And it is amazing how such a simple series of steps can evolve into something that is a very complex system quite fast. So before we move on to the hands-on part of using P5, I want to go through the works of some artists to just to help you understand the sort of work that's out, understand the work in more depth. Also, just to help you get like a perspective of the possibilities, like the sky's your limit here. So these are the Vasulkas. They are known for video art, and a lot of their art is also interactive. So if you look at the image on the right, this was created. So it's like a woman standing. That woman is Steina Vasulka. She's standing with her hand like this. But there are 4 cameras in the room, and these 4 cameras create this overlapping, very interesting overlapping image. And it is all possible by the placement of the cameras and the lighting in the room and things like that. And the movement of her hands will also generate interesting patterns and so on. But this is, I think, a great example of interactivity in just visual art, video art in general. Some more artists that I really want you to think about and reflect on are Vera Molnar and Leah. So Vera Molnar is like a 20th century generative artist. She's one of the most well-known, I would say, one of the most iconic generative artists. And notice that in her works, you will usually see very simple shapes, but you will see how different iterations of those shapes with different sorts of with a little bit of randomness introduced, like with different colors, different strokes, different lengths, different widths. You will notice how taking the same shape and modifying it a little can lead to work that looks super aesthetic and extremely nice to look at. So and the second artist that's on this slide is Leah. They make visual art, and they specifically make they generate art in response to music. So please check out videos if you can find them. But what I want you to see here is that even this image, if you look closely, you will be able to see ridges, or you will be able to see ridges and circles. So effectively, this image is still made using a lot of circles. So it's the same idea of taking a simple shape and moving it around in a way that it generates something very organic and natural to look at. The other 2 people I want to mention are, so Nova Studio is, I think, an artistic duo. They create a lot of generative art and they print it. So their art is, you can buy jewelries, you can buy posters and things. It's really cool because they are taking something that is 2-dimensional on a screen, a bunch of pixels on your screen. They're taking it and they're 3D printing it, and they're actually materializing it. So I really like their work also. It looks very sort of organic. So these look like leaf veins. These are things called L systems, by the way, if you want to read more about them. And the second person I want to talk about is Danielle Navarro. She makes art in R, and she has written a few quite amazing packages to if you know how to use R, and if you want to check out her packages, please check them out. I really love how like if someone presented this image to you besides a watercolor painting, it is very likely that you will not be able to differentiate between the two. So even this is an artist that I really wanted, I just wanted to show you. And before we move on to the interactive part, there are two more things that I would like to sort of flag. One of them is just this quote by Matt Pearson, which I think sums up the philosophy of generative art quite well. He says that generative art is the discipline of taking strict, cold, logical processes and subverting them into creating illogical, unpredictable, and expressive results. And I think that's a really good metaphor. And it is also, in some sense, I mean, I interpret it as a form of protest against the strict and the logical. So that is part of a reason why I personally do generative art. And the second thing that I want to show you is the Encyclopedia of Generativity, written by Kate. So this is like, I think it's a 2 or 3 page it's a 4-page document, and it is full of amazing, like it is full of methods that you can use. It is full of ways you can sample things. It is full of simulations. It has amazing links. It has links to conferences and stuff. So I will share my presentation with you after this. So don't worry about that. But this is something that I just wanted to show you, as this is a 4-page encyclopedia of generativity, which I think is a really good starting point, especially if you're if you are starting for the first time and you're kind of out of ideas. So let's go then. We are going to try and implement the series of steps we made earlier. And in that process, we are also going to learn how to use p5.js. If I would like to get, I would like to get a sense of the coding background of everyone here. Yeah, just so I get a sense of the room. So yeah, I'm going to paste the editor.p5.js link in the chat box. So everyone please open this link and make sure it is in front of you. So what you can do is you can like split your screen so that you can both see your screen and you can see the Zoom window, or you can like zoom out of the Zoom window, or whatever works best for you really. So I'm just going to give you 2 minutes to like get set up. And yeah, so how many of you here would know what functions and variables are? How many of you here know what functions are? How many of you here have written at least the hello world program? Okay. So we have 4. We have 5 people. Okay. We have 6. Okay. We have 6 people. So do the remaining people not know anything about variables or functions? Did you go through the sort of 2 or 3 links that I had sent along with the Eventbrite invitation? Okay. I guess let's get started now. It's 20 minutes past. So yeah, you can lower your hands now. It's fine. So I hope everyone has opened the editor.p5js.org link that I put in the chat box. What I want to do now is just show you what p5 looks like. So there is a way to download it locally. Feel free to go to their documentation page and do that. Their documentation page is very nice. So if you it's quite helpful to just look at and get a sense of things. It is full of nice examples also. So this is what your screen would look like in the p5.js browser window that you have. So there are two functions here, right? The first function is the setup function and the second function is the draw function. First, what we are going to do is we're just going to look at the setup function and then we'll worry about the draw function. And the first thing to note is there is this create canvas thing here. So this is where you'll be able to see the canvas. So what we can do is we can just write something like background. And writing this would show you that this the canvas right now is 400 by 400 pixels, and you would be able to see like a black rectangle on my on the right hand side of my screen and on the right hand side of your screen as well. So colors, so the way colors in p5 work is if you write number, then it means that it is on like a scale of 0 meaning black to 255 meaning white. So something like 150 would result in a grayish color and 255 would result in white. Great. So next, what we are going to look at is we are going to look at coordinate systems, and we are going to first see what the p5 coordinate system is. So you have several shape commands that you can, like you have several shapes that you can draw in p5. And I'm just going to set it to 50 so that it makes life easier. So what I did, why I put the variable outside the setup function is so that it is accessible by both the setup function and the draw function. This is something called variable scoping, which you can learn more about independently. There are a lot of great resources out there like Coding Train, etc. I can send you a few links after the workshop if you want. So let's continue to look at p5's coordinate system, right? So we said that in the top left, it is 0, 0. The width can be accessed by this variable called width. So you can directly just write width to access the width of the canvas, and the height can similarly be accessed by this variable called height. So what did I just do, right? I made 4 circles with a diameter of 50. So the first circle is at 0, 0. The second circle is at width, 0. So if this is 0, 0, this is width, 0. This is width, height, and this is 0, height. Does everyone understand what I did so far? Is everyone with me? Any questions? No? Okay, great. Lovely. So we made 4 circles. Now let's erase them. That's boring. What we are going, I mean, it's not boring. It's still really cool that we wrote 10 lines of code. That's cool. But let's do something more interesting, right? Let's make a circle at the center of the canvas. So to make a circle at the center of the canvas, I would do something like width by 2, height by 2, because that's the center. And for now, I'll just set it to be at the diameter, right? So what we did was we made a circle of radius 50 at the center of the canvas. Now, while that circle is still with us, I will explain the fill and the stroke functions. So we have fill. Again, in fill, your input is something like a color. So let's just deal with single valued input. So 0 means the color will be black. And stroke is the boundary of the circle. So I wrote a stroke of 150, which means it's something like gray. So if I write stroke weight and I put it to be, let's say 10, then you will see how, the boundary of the circle becomes really thick and it's gray because this value I've set it at 150. If I decrease the weight, then the boundary width decreases. If I make it 0, then it vanishes. Right. Another way to make stroke and fill vanish is to write something like, so if you write no stroke, then you will, then there will be no boundary on that particular shape. So if you write no stroke here, then every shape that you draw after this will have no boundary unless you change the stroke later on. And similarly, there is this no fill function, which will negate anything on the fill that you've done. So just see what happens. Circle disappears, right? Because you have no boundary and no color to fill in it. So let's make no stroke go away. So what this means, you have a stroke. So let's increase the diameter maybe to 200 so that it's more visible. So you're not filling in the circle, but you have this stroke of 150. So you have a gray colored stroke, but you're not filling in the circle. Now, let's just quickly detour and look at the draw function. What we are going to do is we are going to draw a circle. So all I did was just write circle width to height to diameter. What draw in p5.js does is it draws everything frame by frame. So if I and there is another, so like you have width, like you have height, you have this variable called frame count. So let's see what happens when we do this. Do you see what happens is okay, let's decrease the diameter to something like 5. So what's happening is more visible. Do you see what happened? What happened was at every frame we draw a circle of diameter 5 into frame count, where so at frame 1 we would draw a circle of diameter 5. At frame 100 the circle would have diameter 500. Does this make sense to everyone? Is everyone with me so far? Any questions at this point? Okay, I will assume that there are no questions. And let's also look at okay, yeah, sure. I'll repeat the frame count. Maybe this will help. So what we are going to do is, oh, sorry, I meant to copy background. We are going to draw frame by frame. So everything that you put in draw, every frame like this, everything that I've written within draw will be drawn at every frame. Yeah, frame count is yeah, it's kind of like a global variable. It keeps track of so you can think of it as like a clock for p5.js in some sense. It's keeping track of the time in terms of the frames. Frame count is available, like it does not make sense to access frame count inside setup. Another question is that is frame count only available inside draw, or can we access it in setup also? It does not make sense to access frame count in setup, because in setup the frame count will not increase. Like setup is just ran once, and after that at every frame, so setup is kind of like literally setting the background up, and then every frame is drawn using draw. So it it does not make sense to access the frame count in setup. But one thing you can do in setup is you can set up a frame rate. So you can have like a frame rate of 1. So if you have a frame rate it will be somewhere in the middle. Does that answer your questions? Kind of. That is a way of looking at it. So let's move on. What's happening? Let's look at what's happening in draw. I will also print frame count with every iteration. You can see that the frame count keeps incrementing, and hence the radius of the circle also keeps incrementing. What we are doing here is that we put a background and then we draw the circle. If we remove the background, then we are not drawing over the circle. This makes sense. Does it make sense why we are seeing a lot of circles when we have a background of 255? So even when we like fill, so if we do something like fill 255, even then we will not see all of the circles inside. We only see those because the fill is 0 or because there is no fill. They are sort of transparent. Does this make sense? Everyone with me so far? So do you understand how to animate a simple circle? Okay, there are no responses, but okay, yeah. Okay, yeah, great, thank you. So now for the time being, we are not going to talk about draw at all. All we are going to do is we are just going to like draw a sort of static image. So this will sort of be what you see at frame count of 1, unless you like draw another background over it. Just to make things, just to like keep things very simple. Yeah. So before we start, I want to introduce the notion of arrays. So I'm going to remove everything about the fill and stroke. I'm also going to comment out this circle. So like here, what we did was we had like these 4 points that we wanted to draw. And we basically typed it all out, right? You can use arrays and for loops to simplify that process, as in so that you don't have to write so many lines of code. So for example, if I want to draw 100 circles, I am not going to sit down and type each one of them individually. I am going to use something like a for loop or a while to essentially speed up the process. So let's see how we can make like how we can, instead of writing this, instead of having the 4 circles at the corner like this, let's increase the. So instead of having 4 circles at the corner like this, how we can use a for loop. So what we're going to do first is we are going to initialize an array. So let's call it my array. Let's call it circle centers. Circle centers is a new array of size. So let me just write the for loop first. So this is what a for loop looks like. Just going over the structure of it really quickly. What this is doing is it will start at an index of, so there is this way, and we will start at 0, and we will keep increasing by 1 until it reaches C. Because let's print this out. Let's just print V out for starters. So you can see that V is 0, 1, 2, 3. So since this is an array of length 4, the way you can access elements in an array is by using the indexes of those elements. So it's something like, maybe let's go back to this drawing page. So it's like we have this list of okay. So we have this list of like we have this list of elements. An array is essentially a list of elements. So if you want to access, let's say, an element A, then you have to use index 0. So if our array is something like this this capital A, then to access, this filled in, this messy ball, what you have to do is you have to write A at the index of 0. So usually start counting with 1, 2, 3. Here it starts with 0, 1, 2, and so on. So if an array has 4 elements, then the count will go from 0 to 3. But we would like, it's like we would count 1, 2, 3, 4, but for an array, it will be 0, 1, 2, 3. So does this make sense? Uh, do does it make sense how to access elements in an array? Great. What we are going to do next is we are going to first make a very simple array, right? So rather than initializing it, we already know what the centers are. So what we are going to do is we are going to make 4 variables. Let's just say center 1. So what I did was I used the create vector function here. Don't worry about this. I'm changing the name. And the create vector function is, it lets you like store coordinates in a special format, which is so it is like a 3D vector. So if you specify 2 elements, then this will be something like this will be something like, so if you were to access like the x coordinate of point c1, all you would do is just do print c1 plus c1 dot x. To access the y coordinate of something, you would just do c4 dot y, c4 dot y. So yeah, so the x coordinate of c1 is 0 and the y coordinate of c4 is 400. So what you're going to do instead of initializing this array is you're just going to like set this because we know them. So C1, C2, C3, C4. And while making the actual circles, what we are going to do instead of writing circle 4 times is we are going to get the element at the zth index. So oh sorry. So let me like remove this. You can see that we still get the same thing. So what's happening here is that for in this for loop, we draw circles 4 times, and we draw it at so at 0 it corresponds to 0, 0. At an index of 1 it corresponds to width, 0, and so on. Does this make sense? Okay. Great. So good so far. What we're now going to do is, I mean, yeah, sure, we know how to generate circles. We are going to generate circles randomly. So how does that work? So rather than specifying these fixed coordinate points, let's just erase it all. We are going to like, first let's decide the number of point circles that we want to generate. Let's say 5. It will be easier to see, right? And now what we'll do is we'll initialize a new array. This array will have num circle number of points. So this will have 5 points. And what we'll do is for every element in the array, we will first create a random center, which is a vector of at a random place in the canvas. So let me break this down a little. Things might have gotten a bit lost at this point. So what we are doing is we are creating a vector of a random width and a random height. So on calling the random function, what happens is you get a random real number between 0 and 1. So you would essentially be multiplying the width by a number between 0 and 1 and the height by a number between 0 and 1. And what you do next is you would set the array element. So the array element at the ith index, you can set it to this random center just to store things. And you can draw a circle, like, because this is what you want the random center to be. So you can see how, at every iteration, so every time I run the code, I get I get circles at new positions because they're being picked randomly. Does this make sense to everyone? Does this make sense? Great. So what we've learned so far is we've learned about arrays, we've learned about for loops, we've learned how to generate a bunch of random circles and make them appear on the canvas. The next thing that I'm going to teach you is, so what was the second part of our steps, if you recall? The second part is that we would like to make a triangle inside a circle. So are people here familiar with polar coordinates? Have you ever heard of that term, polar coordinates? Not too much? Okay. So I will give you a choice here. So what are all of you more interested in knowing about? Are you more interested in knowing about how to handle text with p5, or do you want to learn a little bit of polar coordinates with me and figure out how to make a triangle randomly show up inside a circle? What seems more interesting to you? Second one? Okay, great. Cool. So yeah, so we don't really have a lot of time right now. So okay. So what I'm going to do is I'm just going to show you how to get like a triangle inside a circle. So to do that, we are not making the array and all. Let's just take one circle, right? What we are going to do is we are going to make the center to be some width by 2. Let's lengthwise. And so can you see the circle? So it's just some, does not really matter. The x and y coordinates don't really matter. So this is the circle, right? Now, polar coordinates. So every point on the circle is like so since you're plotting it on the x comma y plane, every point could be something like x comma y. A way, like the way you sort of plot a circle, or another way to plot a circle is using angles. So what you would do is, if you know a little bit of, we have a y-axis, we have a radius, right? For this circle, we have a radius r, we have an angle theta that it makes. So apply a little bit of trigonometry and you'll know that every point on the circle can be represented as something like r cos theta and r sin theta. Okay, this is just a trigonometric fact. And this is what you're going to use. So just to show you what I mean by that, what I'm going to do is I'm going to write like an so x on circle is inter x plus radius, which is diameter divided by 2 uh, into cos, let's say, pi by 2. Similarly, the point y on a circle would be sin pi by 2 with a center y. And what we'll do is we'll just to see where this point is, we are going to plot it. So can you see? This is where, so this is the point at an angle of pi by 2 from the x and y axis and at a radius of diameter by, since the radius of the circle is obviously diameter by 2. So does this make sense? So what we can do is we can use this idea of having arrays. So let's define an angle. So let's write a for loop here. So what you're going to do is we're going to write a for loop for variable. So v is less than pi because 2 pi is the full angle, right? 2 pi or 360 degrees. I'm talking in terms of radians, and we'll increase v by pi by 2. And let's write a for loop for this. So do you see what just happened? You have 4 points on the circle. One of them is at pi by 2. This is at pi. This is at 3 pi by 2. This is at 2 pi. So what you have here is you have a way of finding points on the boundary of the circle. Does this make sense? Because if this idea makes sense to you, then you will very easily be able to understand what I mean when I say how we are going to create that triangle. Does this make sense to everyone? Great. Lovely. So another thing that I wanted to that I want you to see is that we have a total angle of 2 pi, right? So we can divide the circle into 3 sectors. I mean, there can be other ways of doing this. I'm just telling you about this because I feel this is like easy to visualize. Yeah, I guess it would be clockwise. Yeah. So the coordinate system in p5.js takes a little bit of time to get used to because 0, 0 is in the top left and width, height is in the bottom right. So it's kind of ulta if you think about it. So yeah. So we can divide a circle into 3 sectors, right? And what we are going to do next is we are going to find 3 points inside this circle, because what do you need to make a triangle? You need 3 points, right? So before we figure out how to find 3 points inside the circle, we'll figure out how to find 1 point inside the circle. We know that a circle, like we know that every point on the circle's boundary is something like r into cos theta, r into sin theta. So the way that I'm going to find a point inside the circle, there can be other ways, but the way that I'm going to use is that I am going to randomly sample a point of this form. So what I'm going to do is I'm going to have random here. So this is a random point, and okay, let me make variables for that. Let random radius, and this random radius is random into diameter. Let random angle Now, instead of what we are doing is, instead of finding a point on the circle of diameter, whatever we set it to, we find a diameter less than that. So we find a circle inside this bigger circle, and we just find a point on the boundary of that circle. Does this make sense? Is this confusing? Let me plot it. Maybe it will make sense then. If it does not at this point, okay, something happened. What? Sorry. And this changes to do you see what I just did? So the first thing that I did was I randomly chose a circle of the center of the circle. So it's a concentric circle, right? I just find a radius that is smaller than the current radius. And then I find an angle. And to find a point inside the circle, what I do is I find a point on this inner circle. Make sense? Is everyone with me so far? Anybody who got lost? Anything? Are you there? Okay. I will repeat the last bit. So we have one circle, right? So what is the circle that we have? We have a circle. We have this outer circle. Okay. What we want to do, we want to find a point inside that circle. To do that, the first thing that we do is the first thing that we do to do that is we notice that the first thing that we do is that we notice that we can just choose a random radius. So the centers of the circles remain the same. But to find a point inside the circle, we first find a circle inside the circle. And the way we do that is just by randomly picking a radius smaller than the current radius. Everyone with me till this point? Do you understand how to find a smaller circle within the bigger circle? Okay, great. Now, what we do is we pick a point on the boundary of the smaller circle, because we know how to pick, like we know that for every circle, a point on a circle's boundary is just r into cos theta, r into sin theta. So for the inner circle, or the one shaded in gray, we know the radius. We have randomly picked it. All we need to do is just randomly pick an angle also. So if we randomly pick the radius and if we randomly pick the angle, then we will be able to wait a minute, let me just change the order of this. Yeah, so if we randomly pick this inner circle, we first randomly pick the inner circle and then we pick a radius and an angle on the inner circle. Make sense? Is everyone with me so far? So does it make sense? Do you understand how to like pick a point inside the circle? Okay, great. To make a triangle, all we need to do is just pick 3 points. So do you see? Like, do you see the idea now? All we need to do to make a triangle, we need 3 points. Like, we need 3 vertices of the triangle. So we are going to pick 3 points inside the circle. Let's do it. We already know how to pick 1 point. To pick, like, but you can see how writing this is a little bit tedious, right? So rather than writing this, what we can do is we can make a function, or we don't have to go into functions. We can just write a for loop. What we're going to do is we are going to write a for loop for variable for so since we have to pick 3 points, we will be 0, 1, 2, and we can initialize an array of triangle coordinates, triangle C, as new array 3. And the next thing that we are going to do is we are going to just copy paste this code inside. And we are going to set the triangle, like we are going to set each vertex of the triangle to be something like okay. So this is how we pick. Oh, sorry, I used the wrong brackets. Very sorry. So this is how we've picked 3 points randomly. All we need to do is just plot the triangle. So I'm just going to make the size of this smaller so that it's easier to write. So now I'm going to make the triangle. So the triangle will be something like, so the first point, as in the 0th index, its x coordinate, and then it's, oops, sorry, dot x, dot y. This will be 0. This will be 0. Then we go to the first index of the coordinate array, and then we choose its x and y coordinates, and then we go to the second index of the triangle array, and then we choose its x and y coordinates. Do you see? Does this make sense? So what you've just done is we've randomly picked a triangle inside a circle. Now, there's a catch here. It is possible for us to pick 3 points that lie on the same line. To prevent that, what you can do is you can limit the angles that you sample from at every point, which is why I showed you that 3 sector sort of a diagram. So if we have enough time, I can teach you how to do that. But for now, what we've learned is we've learned how to make a lot of circles randomly, and we have learned how to make a triangle inside a given circle. What I want you to try and do after this workshop is use if-else statements to implement the steps that I wrote earlier. Like, it will be great even if you can figure out how to, so if you have a bunch of randomly generated circles, how do you get triangles in all of them? It will be great if you can figure that out also. Do I have enough time to show the sector idea, or do we need to end the workshop right now? Could you please let me know, Caroline?
Yeah, so the workshop can go on for a few more minutes if everyone else would like to stay.
Okay.
I'm not really on a time crunch or anything. I see in the chat we have a few people, we have someone willing to stay. So you can go over that for the next few minutes.
Okay, yeah, thank you so much. So the next, so by sampling from a sector, what I just mean is we can divide this circle into sort of 3 parts. So this is some angle, and okay, I'm sorry, my handwriting is so bad. Let me just write θ1, θ2, and θ3. So the easiest way to do this would probably be to just have so you start at 0 and then you go to 2 pi by 3, and then you go to 4 pi by 3. So this whole thing will be 4 pi by 3, and then you go to 2 pi. So what would this mean? How would we implement this. So essentially what we're doing is we are restricting the angle for each coordinate. So how that would work is you would have something like, so you're sampling only from 2 pi by 3 angle, right? You're only sampling from 1/3 of this circular region. All you do is you offset that by either 2 pi by 3 or 4 pi by 3. So that is the idea. Like we randomly sample from a 2 pi by 3 region, and then depending on which coordinate it is, we multiply it by 2 pi by 3. Let's just see what happens. Let me also make the 3 lines that I had made earlier, so it's easier for you to see. So do you see how the 3 endpoints are also in 3 different sectors? Like one of them is in this sector, one of them is in this sector, and one of them is in this sector. So this is like a very simple sort of a way to like make sure your triangle looks enough like a triangle and not like some very thin monstrosity. Like there are other ways to do it also, but this is like a possible simple way to do the same. This is all that I wanted to share. I really hope that you had fun. Let me just do this one last thing, and what we are going to do is we are going to animate the sequence really quickly. So just to like draw a bunch of random triangles. Okay, what happened? Okay. Oh, I'm so sorry. I'll just copy those. Diam is what, 100, 200? Sure. Like you can see, right? You can see like this is what we did. So this is just like an animation of all of the random triangles that we have. So I hope this made sense more or less. And I mean, I know we necessarily did not make something very visually pleasing, but the idea of this was to just show you what you can do with very simple shapes and to hopefully like inspire you and give you a little bit of confidence to start experimenting with art made using code on your own. Because I know how intimidating it can be to just like open a code an editor and just be overwhelmed by, you know, all of the different things that you're seeing. So yeah, I really hope you had fun. Thank you so much for coming on a Saturday evening and staying. Very grateful to Backslash and everyone who attended. So thank you. Yeah, over to you, Caroline.
Yeah, thank you so much, Hetvi. This is such a great overview of generative art, and I love seeing the examples in the beginning as well. So just to wrap it up, I'm going to put some links in the chat where you can support Hetvi and see more of her art. So if you create something from this workshop, feel free to tag her or tag us, and we'd love to see what you create. Let me just paste that in the chat. I've also put some links to the Internet Freedom Foundation if you'd like to take a look at their mission and donate. And finally, I also have some links for /lit if you're interested in contributing some work for our magazine. So next week we have another event as well. We're going to be doing live coding with another guest contributor. So if you're interested in music or music making, you can register for next week's event in the last link I sent. And that'll be it. So thank you all for staying. Thank you all for participating. And I hope you have a great weekend. Stay safe. Take care. And thank you so much for coming.
Yep. Thank you so much.
Thank you, everyone. Bye.
Bye.